Pythagoras theorem, the very famous Pythagoras theorem. So it concerns a right angle triangle, any right angle triangle. And then the side opposite to the right angle, which would also happen to always be the longest side in the triangle, is called the hypotenuse. I think it's spelled like this, probably. And we call it C. And then for the other two sides, it doesn't matter. One is A, one is B, doesn't matter which is which. And Pythagoras theorem tells us that if you square the side length of A plus the side length of B, well, plus the square of side length of B, it would equal to the side length of C squared. Alright, Pythagoras theorem. Simple as that, but some common misconception is why can't we just root both sides, and so we have A plus B equal to C. The reason why we can't do that is because there's a plus in between. So when you root something plus something, it is not the same as root the first plus root the second. Hence, you can't do this. Second thing is, I can't stop myself but to want to prove Pythagoras theorem to you. If you're completely not interested, then skip to the later part of the video. But he is one of, there are many proof of Pythagoras theorem available, and this proof is, I think, the one of the easiest one, and it's also the one that I first learned when I was a student. So do this. So you consider you have this right angle triangle, but you put it like this way. So this is the A, this is the B, this is the C. And then you make 4 copies of the same triangle. Okay, so another copy, but this time you put it like this way. So you put the B side here, the A side here, and the C side here. And then another copy, you do the B side here, the A side here, and the C side here. And then the last copy, you do the A side here, the B side here, and the C side here. Okay. So if I've drawn it perfectly, alright, what happened is this inside would be a perfect square, okay, would also be a square, okay? Which means we can try to calculate the area of this whole thing, right? Because the inside is a square, so the area of that square would be the side length square, so C square. And then I want to add the 4 triangle on the side. Well, the area of triangle is base times height divided by 2, and then times 4, because there are 4 of them. But you can also look at the whole picture as like one big square, right? This is one big square. So the area of that one big square would be the side length, which is A plus B times the side length, so we square that. And the 2 different ways of calculating the area of this picture should give you the same result, so they equal to each other. Then we'll do some algebra. So 4 is like 4 over 1, so the 4 and 2 cancel out. So this is 2 times A times B, so it's 2AB. And then we need to expand this bracket. So A plus B squared really means A plus B times itself, so A plus B times A plus B, so we'll expand. So A times A is A squared, A times B is AB, B times A is BA, but that's also AB, they're the same, and then B times B is B squared. Okay, then we simplify the right, AB plus AB is 2AB, then we basically. Oh, but this is a squared, this is also a squared, so you don't cancel out. And so we get that a squared plus b squared equal to c squared. Okay, so I like this proof quite a lot. Let's look at what we do with Pythagoras theorem. What we can do is pretty straightforward. If they give you a right angle triangle and tell you 2 of the side, then you can find the length of the third side using a squared plus b squared equal to c squared. Now the only thing you need to be careful of is that the c must be the longer side, like the c must be the hypotenuse, which is the side opposite to the right angle. So here c would be the unknown x that we are looking for, and then ab doesn't matter, you can just put it in. This is a topic where it would be nice if you can memorize most of the squares. So 4 squared is 16, 6 squared is 36. And we add them up, I think it's 52. So x squared is 52. Then we mean x is the square root of 52. Okay, because the square root is the opposite of squaring. So at this video, we'll just leave the answer like this. We probably would not try to simplify these or get a decimal. Okay, let's not do that. Okay, that's Pythagoras theorem, simple as that. Let's try another one. Maybe this one. So again, we do Pythagoras. But this time be careful that the unknown is not c, right? The side opposite to the right angle is a c. So it's the 7, that's the c. So a and b doesn't matter. So I'll put a as 2, b as x. 2 squared is 4. 4 squared is 49. Then you minus, then you get what? 45. So x is root 45. Okay, which again is not a nice number. And so you can ask, is it possible to get nice numbers as answers? Like, is it possible for a, b, c to be all nice numbers? The answer is yes. And when that happened, they're called a Pythagorean triple. And one example of Pythagorean triple is 3, 4, and something else. Okay, you might want to calculate this. Pause the video now. Give it a try. Trying to find x. This is coming. 3, 2, 1. So we have a squared plus b squared c squared. So 3 squared plus 4 squared. Supposed to be x squared. 2 squared is 9. 4 squared is 16. 9 plus 16 is 25. So if x squared is 25, x is 5. So turn out 3, 4, 5 is a Pythagorean triple. Now once you have one Pythagorean triple, you would have infinitely many, because it happens that the multiple of a Pythagorean triple would also be Pythagorean triple. So for example, 6, 8, 10 would also be 1. And then what? 9, 12, 15 will also be 1, so on and so forth. Okay? But not all Pythagorean triples are multiple of 3, 4, 5. Another such example would be maybe 5 and then 12 and then x. So we have a squared plus b squared equal to c squared. 12 squared equal to c squared. So 5 squared is 25. So this is where it would be nice if you can memorize a lot of squares. 12 squared is 144. If you add them up, you get 169. And it would just so happen that 169 is 13 squared. Alright, so 5, 12, 13 would be another Pythagorean triple. So in case you want to quickly memorize all the squares from say 11 to 20, I can quickly calculate it for you. Then you can try to memorize it. 11 squared 121. 12 squared is 144. 13 squared is 169. 14 squared 196. 15 squared is 225. 16 squared is 256. 17 squared is 289. 18 squared is 224. 19 squared is 361. And then 20 squared is 400. Okay, so that one is less interesting. But it would, I think, really help if you can memorize these when you're doing this topic of Pythagoras theorem. Now, very lastly, it's possible for you to see questions where a length of the triangle is already a square root. So maybe you see something like this is root 3 and this is 5. Is 5 too big? Maybe root 5. Okay, do root 5. So I want to show you how to quickly do something like this. So again, it's a squared plus b squared equal to c squared. So the c is the hypotenuse. So it's root 5 squared. AB doesn't matter, so I say it's root 3 squared plus x squared. Now, as I said, the square root is the opposite of square. What that means is the square root and the square would cancel out, which means the square root of 3 squared is just 3. Okay, the reason for that is square really means the thing times itself. And when you have a root times another root, you would just times the number inside. So it's root 9. And of course, root 9 is 3. Okay, so a square root and a square always cancel each other out. So root 3 squared is 3, x squared is x squared. Root 5 squared is 5. So x squared is 2. And x would be root 2. So that's how you deal with a root. So let's do one more. This is root 5. This is 3. And find this. Give this problem a try. Answer will be coming. 3, 2, 1. So again, a squared plus b squared is c squared. So x squared plus root 5 squared is 3 squared. So 3 is the longer side, right? So x squared. Root 5 squared is 5. 3 squared is 9. So x squared is 4. So x is 2. Okay, so that should be it. And of course, you want to find some exercise for practice. If you have like some math textbooks, then do that. Should be fine. If not, and you're looking for exercises, you can join my membership level 2, where there would be suitable exercise under the basic series.